Okay, here I am ready to do part A of the 2025 lab assessment. So first of all, before you do anything, you should read carefully through the question, so let me at least mime doing that. In Lucidchart, using its UML shapes, draw a UML class diagram showing a list of things. Okay, so we're asked for a couple of classes and an interface, and appropriate relationships between those classes and the interface, realization, it's saying, and another class with a private Boolean attribute, and an association, blah, blah, indicating that a holiday involves visiting, blah, 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 blah. Okay, we've got some multiplicity information there, fine. We'll come to that in detail in a moment. Show operations in the classes and navigability of the association in such a way as to be consistent with the following sequence diagram. Okay, you should be thinking, obviously what she's doing here is she's checking not only that I know how to draw a sequence diagram, but also that I know how to draw a class diagram, but also that I know how to read a sequence diagram. Excellent. Note that the sequence diagram omits some relevant information about the operations, but your diagram should include sensible choices. Okay, and looking at the diagram, it's pretty clear, I think, that the relevant information we're talking about is types and visibility of the operations. Maybe there's also an issue about what appears where in classes versus the interface. Again, let's let that come out in the wash when we get to it. We've got plenty of time. Right, so I've got my UML shapes ready here. We're going to start off by putting in some classes, and because we know we're going to want attributes and operations in at least some cases, let us use the three-part UML class. So there's that one, and we'll have that one. Let's do those two to start with. Now, I think I'm just going to name them for now, and then I'll worry about the attributes and operations in a bit. So this is going to be beach holiday. And this one is going to be walking holiday. Okay. Now we need an interface holiday. There's the interface sign. I'm going to put that one up there. Okay. Actually, from bitter experience, I'm going to move these down a bit so that we have more space to show the difference between a solid and a dashed line in our relationships. Because we now have to put appropriate relationships to indicate that beach holiday and walking holiday realize holiday. Okay, so let's first of all put in any old relationships, and then let's worry about getting the precise UML notation correct. Okay, so this one is selected now, so let's do this one to start with. I always find it slightly disconcerting that Lucidchart doesn't update the association until I click away from it, but I'm used to that from the labs, hopefully you are too, so we won't worry about it. So let's make the line width just a bit bigger, just for appearance sake. I'm going to make it a dashed line because that's how realization is shown. And I'm going to select the correct kind of head, which is that one. And hopefully that should be correct. Don't want any multiplicities. Yeah, so that looks like a jolly good realization error. Now let's do the same with the other one. We'll make it slightly wider. We'll make it dashed. We'll give it the correct head type. And we'll click away to check that that worked. And it did. Good. 2 realization errors. We've got a good number of marks at this point, we're hoping. Now, next, a class destination with a private Boolean attribute is by C. Okay, where's our class gone again? It's down here. A class destination. I always click the wrong number of times selecting my text. Destination, and we want a private Boolean attribute, so we may as well edit the one that's conveniently given to us as being private. It's going to be is by C, and it's going to be Boolean. while I'm at it, I may as well delete the other attributes which I'm not going to need, it seems. Just for fun. Let's just tidy that up. Good. Okay, what next? An association between holiday and destination. Holiday and destination, you see why I laid them out this way. Indicating that a holiday involves visiting at least one destination, while a destination may be visited by any number of holidays, including 0. Okay, so we're obviously being asked to put some correct multiplicity information in here. And this time I think we will have a name. Let's go, whoops. Oh, yes. I wonder if we can move that off the line. We can, good. Okay, now we're going to need some multiplicity information. Now, what are we being told? We're being told a holiday involves visiting at least one destination. A holiday involves visiting at least one destination. So at the destination end, we need not 0 ... star, which is the default, but 1 ... star. Okay, good. While a destination may be visited by any number of holidays, including 0. Okay, so on the other end, the 0 ... star is correct. Right, fine. Now, the only other thing we have to worry about is the arrowhead. Now, that's wrong for any kind of arrowhead in a class diagram. So for now, let's make that go away entirely. And we may get some more information when we look at the sequence diagram, which is where we've got to now. Okay. Now, show operations in the classes and navigability of the association in such a way as to be consistent with the following sequence diagram, which shows a message going from a client to a walking holiday, then from a walking holiday to a destination and return, then a self-message going from the walking holiday to itself, and then finally the initiating message from the client being replied to. Okay, so the easiest possible thing to deal with is the navigability of the association, because since in the sequence diagram we see a message being sent from a walking holiday to a destination, that means the association from holiday to destination had better be navigable in the direction of destination. So let's set that up. We're going to need that kind of arrowhead, because that's what navigability in an association is. Ah, it's on the wrong end. So we had better reverse the line direction so that it ends up on the right end. Okay, so navigable from holiday to destination, consistent with the sequence diagram. Right, now let's have a look at the operations. So there's an operation being called on a walking holiday by the client, that is a message being sent from the client to the walking holiday. It's called leaving time and it has parameters airport and arrival time. Okay, so now we need an operation in walking holiday. We might say, okay, walking holiday realizes this interface holiday. So do we think we want the leaving time operation to be just in walking holiday, or do we also want that to be specified in the interface holiday? I think we should show it in the walking holiday because that's where the actual implementation is. It may be that we also want to show it in the holiday interface. So let's think about that in a moment. But to start with, let's just put this operation that we're going to want in. Oops, there we go. Now, it's going to be called leaving time. It's going to take some parameters. Okay, it's going to take parameters airport. I'm going to guess that that's just going to have type string. And it's going to have an arrival time. Let's suppose that has parameter that has type time, shall we? We're assuming here that there's a time type in a library or something, but we can do that kind of thing. And the return type is also going to be time. So let's put that in now while we look at it. Okay. Now, the next thing that happens is that the walking holiday sends a message location to a destination. So let's put that message, that operation location into the destination class. An operation called location. It takes no parameters. And let's again assume that there's a location class in some library because it might have to include latitude and longitude or something. Now the only other thing is that we've got the self-message coach plan, airport location and arrival time. And since that's a self-message, it could be private. And maybe now is a good time to think about the relationship between the interface. Now, different choices were possible, so there were different ways to get the marks here. But I think the obvious thing to say is let's assume that the leaving time is part of the interface that Holiday implements, in particular because reacting to it involves interacting with the destination. And we know that the relationship between holidays and destination is already present at the interface level. But maybe this coach plan thing might be specific to a walking holiday. So I think we might make that private and assume that that's just part of the implementation of leaving time within the walking holiday class, just for fun. Like I say, different choices are possible. And there were different ways of getting the marks. So let's go. Coach plan. And this is going to be, it's going to take an airport, and it's still going to have type string because that's what I said before, and location, which is still going to have type location, and arrival time, I can't type, which is still going to have type time, and we don't know anything about the return type of that. And it might be that we don't need a return type because since this is a private operation, it might well be that it just updates some internal information about walking holiday. So I think we might just leave that open actually at the moment. Now let's delete that operation, which we're not going to need. Okay, we decided, didn't we, that we're going to have a leaving time in the I wonder whether I can copy and paste. That would be way too convenient, wouldn't it? Oh, I can. Very good. So now let's delete those ones. Oops. Let's note that. Come all on one line. Let's tidy things up a bit. You don't have to have your diagrams very tidy to get the marks, but there's sort of limits to how untidy I want my diagrams to be here. So leaving time, airport string, arrival time, returning time, public. Okay, this is good. So I think all I now need to do is to delete the stuff I don't need, which you should do because you don't want to leave meaningless operations with names like operation 2 lying around. So let's get rid of all those attributes. That one's fine. Let's get rid of all those attributes. And now I suppose because Beach Holiday is supposed to implement the interface, Beach Holiday will at least also have to have an implementation of this leaving time thing. So let's copy and paste that again. And again, this is a refinement, and different choices were possible. Okay, and now I would read through the entire question again and just make sure I haven't missed anything. But I think I have not. Okay, now let's go on straight on and do question 2 since we're here. Add a note to your UML class diagram. In it, write an OCL class invariant in full, not just the OCL expression itself. Okay, so that's checking whether we noted that we have to put context something in, right? To specify that for any valid instance of beach holiday, at least one of the linked destinations must have is by sea set to true. Okay, so where's our note? I had a note a moment ago. There's our note. I'm going to put it down here. Make it a bit bigger. I'm going to type in the middle. So we're going to go context beach holiday in colon. That sets us up to say what we're doing is we're writing a class invariant for class beach holiday. And there's different ways of doing this, but what we can do is we can just go self dot destination lowercase to indicate that it's the set of objects which are linked to us by the association to a thing whose type is capital D destination. And if you remember your OCL, there's multiple ways of doing this, but the simplest is just to go is by C, which is short for self.destination arrow exists is by C. So self.destination is a set of destinations. Exists is going to say within that set there exists at least one element that satisfies the property in brackets, and the property in brackets is just going to be is by C, which we can do. Okay. If you wanted, by the way, to attach this by a dashed line to beach holiday, then it would have been okay to miss out the name context beach holiday, because that's an alternative way of saying that that's the context in which this OCL invariant is to be read. That's it.